Now we will have a look at the coordinate system. So everything that has to do with the axis, for example. We will have a look at some examples. So for example, the log10 transformation and also the axis limits and zooming. So here we have an example of a scatter plot again from the Gapminder dataset. So what we did is here plotting on the x-axis the GDP per capita and on the y-axis the life expectancy, and it's colored by the continent. And what you can see is that this shape here means that there are actually a lot of countries, especially from Africa here on the lower GDP side, where you can't really see much because they are like squished together a lot. And this would be actually a good example for transforming the x-axis with the log transformation. And of course, it would be now possible to change this in the dataset to log10 transform the GDP per capita before starting to plot. This would be one possibility. But there are also possibilities to do this directly with ggplot functionality. One of them is to use the coord trans function. So this transforms the coordinate system, and then you describe which coordinate you want to transform, in this case the x-axis, and then which function to use, which is log10. And then you see that a log10 transformation is applied, meaning you can now see more clearly countries with a lower GDP. And you see that also the grid changes. So it's basically now a log scale here on the axis and on the grid. There are some alternatives, so using the scale x log10 function or the scale x continuous function with a transform equal to log10, and we will see in the exercises what kind of effect this has on the plots. Then you can also do zooming as an alternative. So in this case, we use the xlamp function to set it from 0 to 10,000, meaning that it will only plot the data points between 0 and 10,000 GDP, and lets you also see a bit more clearly the low GDP countries here. If you do this, you will encounter a warning message that it removed 54 rows of your data. And these are all the rows that contain countries with a GDP over 10,000 in this case. So the data you don't see, they are also removed from the data before plotting. This usually does not have a high effect on how the plot looks like, but it can have an effect on anything you do with the data. For example, if you calculate some kind of mean value or if you add a linear model to the data. And this is what we can see here. Just a simple scatter plot with a linear model. This is the original plot. And now we use the functions xlim and ylim to zoom in. And then you can see that the linear model here is recalculated only on the visible data. So this means that this function uses clipping, so really removes the data points. While if you use, for example, the coord Cartesian function to set the x and y limits, then it will use it without clipping. That means that the original linear model is shown that was here in the original plot. So it doesn't remove the data points, but it keeps them in the background. In plots, you have also different kinds of labels, which are really important to give information to the viewer what he or she is actually seeing in the plot. This can be axis labels, this can be titles, custom text within the plot, or really labels of specific data points, e.g. for highlighting them. If you want to modify labels, you can use the labs function, which allows a lot. For example, changing the title, the subtitle, the X and Y axis titles, tags, You see here this an A. This may come in handy if you want to combine different plots with each other. And it can also have a caption, which is then below this plot here. So you have a lot of option within this labs function. If you want to add text to a certain part of the plot, you can use, for example, the annotate function with geom text. And then you specify with X and Y the position of this text. Label is the text itself. With this \n, you can introduce a new line, for example, and you can define the color, the size, and for example, here it's in bold with the font face. And then you see that here some text is written now into the plot. In this example, the geom text function is used to label the numbers in a bar plot. In this case, you can use the AES function, then define a label. In this case, it's based on the population column and it's formatted so that it has the comma as the big mark, like you can see here. For 1000, there would be a comma in between. And you can adjust the position a bit, and then you can see here that always above the bar there's the actual number printed, so you can compare them even more directly. You can also do the same with the geom label function, which then puts a nice background and a border around these numbers. In this case here, you may want to use show legend false, because otherwise it will also change the appearance of the legend here. You can use a similar thing also to mark certain single data points. So in this case, we want to highlight Germany in this point. So we use the geom label, but a specific version of it. So the so-called geom label REPL from the ggREPL package, which tries to avoid overlap with any other labels or data points. So it doesn't plot the label here and maybe hide some other data points, but it tries to avoid that. For that, we use again the filter function to filter out only the single data point for Germany. And we use the AES to define the label as the country. And then nudge Y and X would allow you to move it around a bit on the X and Y axis. Again, show no legend, make it a bit larger with a size of 2. And then you see that Germany here is nicely labeled in this plot without hiding any other data points. So now it's time to practice the changes in the coordinate system and the labels. So please have a look at the exercises 3.5 to 3.8.